In the previous section, we looked at graphs of polynomial functions and different characteristics about their graphs being smooth and continuous. And one really important thing that we discussed were x-intercepts or zeros of these polynomial functions. What we'll see here in 3.3 and 3.4 are different techniques for finding these zeros of a polynomial function. They're usually not that easy to find. One technique we saw earlier was to do some factoring. Well, in 3.3 we'll look at some division of polynomials that will help us find zeros of polynomials. Okay, so we'll use division as a technique that will help us factor a polynomial and then find some zeros. Now, the book discusses long division, but we're not going to go through long division, assuming that you've done some long division before this class. We're going to look at something called synthetic division, which is a quick method of dividing polynomials, but your divisor has to be in the form of x minus c. So it only works for those type. One thing we also have to remember is our polynomial has to be in descending powers, and we have to put a 0 in place for any missing powers. So let me show you the setup. It's a real simple operation. Let's check out the setup. So let's see how this stuff comes down. First off, I'm going to draw a box here, and the number in our divisor, just the number, is going to be recorded in the box. But if you notice, between the number and when it goes into the box, there's a sign change. So when we divide by x plus 3, in the box we have to put a minus 3. So watch out for that. Always, when it's in this format, there's a sign change. Now let's look at these numbers. All I'm doing is dropping down the coefficients, the coefficient of 2, coefficient of -7, coefficient of 5, but notice when I bring the coefficient of 5 down, I skip a spot and I put a 0. That's because when this thing is in descending powers, there is a skipped power. It goes from 3 to, it skips the first power, then goes to the constant of 5. Whenever there's a missing power, we have to put in a 0 for a missing power. We'll put a 0 in for missing terms. And the missing term there is the first power. So now that's how we're going to set it up. We'll put the number in the box from the divisor, list all the coefficients, making sure we put zeros in for missing terms or missing powers. Now here's how the process works for synthetic division. To get started, we always drop down the first coefficient. So we're going to drop down the coefficient of 2. First thing always, not this 3, the 2 drops down. Now it's just a series of multiplications and additions. Some of you have probably already done this before, but we multiply the -3 times the 2. So we're going to multiply that, and we're going to put the answer right there. -3 times 2 being -6, and we put the answer above the line. So we multiply -3 times 2, put the answer above the line. Then these guys here are added or subtracted. So we'll add or subtract these and put the answer below the line. That's going to give us what? -13. Now we do the multiplication again. We multiply the -3, multiply the -3 times the -13, another multiplication. Put that answer above the line. So -3 times a -13 would be a positive 39. Add that to 0, and 39 comes down. So we add those two values together. One last multiplication, and that's the -3 times the 39, and we're going to put that answer above the line. What's that going to be? That'll be a negative. That'll be a 27, 117. Let me come on the side. I don't have my calculator real quick. 27, Yeah, 117. And then finally, we do one last addition for this problem, which is a negative 117 plus a 5, which will be a negative 112. So that's the procedure of synthetic division. Now, I don't have enough room here to actually state my quotient remainder because I kind of ran out of room, so I'll put it below here. So this is where our quotient, our remainder comes from. The remainder will always be this last number, negative 112. The quotient will come from the coefficients preceding that. So these will be the coefficients on our quotient. And now, since our problem started off when we divided, it started off as an x cubed power. Your quotient is going to decrease by 1 degree. So this will start off with a square, then it'll be an x term, then it'll be a constant. So these are the coefficients. We go ahead and write in the x values for a final quotient of 2x squared minus 13x plus 39, and then the remainder of negative 112. So that's the procedure for synthetic division. And what we'll do is we'll continue and work on that procedure here on these next examples. So let's remember the setup. Start off with the box. And for this problem, what number is going to go in the box? We take this number right here, put it in the box, but we have to remember to change its sign. So in the box, that one's going to be a negative 5. Then we write down our coefficients. The first coefficient is 4. Now there's a missing term because it goes from a square to a constant, so I need to put a 0 for the middle term that's missing. Then the negative 3. So positive 5 becomes negative 5 in the box, then 4, missing first power, negative 3. Then we'll draw the line and just start our synthetic division. So the first thing we said was to drop that front coefficient down. Then we do series of multiplications and additions. So we'll multiply these two. Negative 5 times 4 is a negative 20, and we put that number above the line. So that's a negative 20. Adding those two together, we get negative 20. Now let's multiply again. Negative 5 times the negative 20. Put that above the line, that gives us a 100, positive 100. And when we subtract these, it's always an addition or subtraction depending on the signs. When we subtract these, we get a 97. So our quotient right there, and our remainder is right there. Where is my line? There it is. Let me fix that. Our remainder is going to be here, 97. And our quotient's going to be a 4. Now what's the power going to be? Since it was a square, and if I divide a square out by an x, it's going to drop down to a first power, and then there is the rest of it. There's the constant. So it started off as a square, the quotient is going to be a first power, and our remainder comes down to 97. Let's set the next one up. In the box, I'll take that, change its sign, and put in the box a positive 2. Let's list all the coefficients. It's in descending powers, so the coefficients are 1, negative 1, 1, negative 1, and 2. Let's drop down the first coefficient, and let's start the procedure. 2 times 1 is 2. Subtract 1, we get 1. 2 times 1 is 2, plus 1 is 3. 2 times 3 is 6. Minus 1 is 5. 2 times 5 is 10. Plus 2 is 12. Now it's real easy to make a mistake doing this. Let me go back and check my work. 2 times 1 would be 2. 2 minus 1 would be 1. 2 times 1. 3, 6, 10, 12. So let's list our quotient remainder. This was a fourth power, so when I come down to the end, I know this part is my remainder. The quotient is going to start off as a cube. So this will be a 1x cubed, then a square, then an x, then a constant. X cubed plus x, oops, I said cube and wrote square. X cubed plus x squared plus 3x plus 5, remainder of 12. Okay, let's set the last one up. What goes in the box is a 1/2, going from negative to positive. Coefficients would be 4, a 0 because there's a square missing, -5 for the x term, and then a 2 for the constant. And let's drop down the 4, and let's work it out. Half of 4 would be 2. 2 plus 0 is 2. Half of 2 would be 1. -5 plus 1 is -4. Half of -4 is -2 plus 2 is 0. Watch your arithmetic. Remainder here is 0. The quotient is going to start off with a coefficient of 4, and since the original was a cube, this is going to drop down to a square, then a 2x minus 4. Square, x, constant. Now in the book they may give you some answers, and even in the exercises when you're working in Course Compass, where they'll write the remainder. Instead of writing it like in this one as a 97, they might write the answer as a 4x minus 20 plus 97 over x plus 5. This one might be written x cubed, oh, forgot my square, plus x squared plus 3x plus 5 plus the remainder over that divisor, x minus 2. And then this one could be written as a 4x squared plus 2x minus 4 plus a remainder of 0 over the divisor, x minus 1/2. I think for the most part they'll just want you to list the quotient and the remainder like this, but if you see some answers, or if they ask you to write it in this format, just notice all it is that remainder over the divisor, the x plus 5 or the x minus 2 or the x minus 1/2. Now I want us to make some connections given what we saw on the first page. So let's go back to what we did way in the beginning of chapter 2, working with function notation and finding some function values. So let's go back to old notation and find f of -5. Remember, that was just plugging in a -5 everywhere you have an x and then just doing the arithmetic. So -5 squared would be 25. So 4 times 25 minus 3, 100 minus 3, which is 97. Let's take this one and plug in a 2. 2 to the 4th minus 2 cubed plus 2 squared minus 2 plus 2. Putting a 2 everywhere we have an x. 16 minus 8 plus 4 minus 2 plus 2. Those cancel. 16 and 4 is 20. 20 minus 8, however you choose to do that, we should come up with an answer of 12. Then finally f of 1/2. 4 times a 1/2 cubed minus 5 times a 1/2 plus 2. So it'd be 4 times 1/8 minus 5/2 plus 2. And the 4 times 1/8 becomes, if I do some cross canceling, because it's like 4/1 times 1/8, so 4/8, I get a 1/2 minus a 5/2 plus, I'm going to call that 2, an equivalency dealing with a half, so it would be 4/2. So I end up with -4/2 plus 4/2, which is 0. So let's look at these three answers, 97, 12, and 0. Those three function values. And if we go to the previous page, we'll see a connection. Notice the remainders on the previous page were 97, 12, and 0. Interesting. When I found function values, notice that the answer to the problems we just did were the remainders to these synthetic division problems we did previous. So what's the connection? Connection, one of them is this. The remainder in synthetic division is actually a function value. The remainder in synthetic division is actually a function value. Now let's also make a connection about this number that we have here. Notice I plugged in a -5, plugged in a 2, plugged in a 1/2. And on the previous page, that was the number, those were the numbers in my box. A -5, a 2, a 1/2. Same numbers in the box. But be careful, these guys I had to take the opposite sign of when I went from here to here. But notice the number in the box is the actual number that we put in the polynomial on the next page when we found the function value. So in synthetic division, the remainder is actually a function value. We'll just call it f of c. I don't want that. I want this.